Who am I? My name's Matt Hope. I work at Nine. Previously, we were Fairfax Media, and we're now part of Nine's publishing division. Nine, you're probably all aware of Nine Entertainment, Channel 9, but we're the part that also does Sydney Morning Herald, Australian Financial Review. So, Fairfax Media started as the Sydney Herald back in 1831. So we're nearly, not quite, but nearly 190 years old. And these day and age, it's very hard to pivot a 190-year-old behemoth that's going down the train tracks and trying to get that to shift to be a lot more agile, a lot more cloud native. So this is a bit of the journey and the opportunity we had. One of the reasons for this is we had a lot of competing interests. So these days you've got Facebook, you've got Twitter, you've got random blogs. There's stuff all over Medium that directly competes with the Sydney Morning Herald. So we needed to do something. This is our journey. We started off with a lot of planning. Now, we got an opportunity, a very, very fortunate opportunity in that they decided to do a bit of a corporate reboot and have a chance to do a greenfields new build inside of this very, very large legacy company. And this was not just a technology reboot, it was not just a technology rebuild, it was a whole of business. We got the opportunity to grab people from our advertising, our editorial and other parts of the business to work out how are we going to do this, how are we going to make media useful, do this bit of a reboot. And this was actually before we became Channel 9, so this was still the Fairfax Media. Where did we start? So, very first thing we did was we set up a Kubernetes cluster because that was one of the things at the time. This is about 2 years ago now. About this time when we were kicking it all off, actually about the time we launched this into production, we were running about Kubernetes 1.6, and that was the cutting, bleeding edge thing at the time. From the very first day, we had development teams that needed a reliable, stable infrastructure. So Kubernetes ended up to be a really good bet for us. At the time, we weren't sure. There were a lot of other competing things. There was Docker Swarm was looking like a feasible alternative at the time, but turns out we made a good bet and stayed with Kubernetes. There are a lot of unknowns though. There's a lot of things that we didn't know what we needed to know. We didn't know what was going on. So we're switching from monolithic, in some cases, Java application to this new cloud native, shiny new, awesome microservice, whiz bang woo Kool-Aid day. And a lot of the problems were, back then especially, not many people had much experience with Kubernetes. It was a bit of a new, strange, unusual, different beast. Not many people had a lot of experience with microservices. There's, as previous days mentioned, there was things like SOA, and microservices are kind of a different way of cutting and looking at SOA, but it was very, very different. There are a lot of other things going on. Back then, no one ran Kubernetes at scale. There was little deployments, there were little things that people had done. There was, oh, I've got one little application running in production, but not everything in production. And we've actually gone down the path where absolutely 100% of our workload is in Kubernetes. We started off with a few key assumptions, and we started off with a lot of almost rules or things that we bound ourselves to make things consistent, standard, and useful. One of the things that turns out it was a little bit different that not a lot of people do is having a very, very large number of namespaces with very little a small amount of things in it. So for our application, some of our applications, we've got a namespace for every single application and a namespace for every environment that application runs in. Very, very different pattern to what I've seen in other places. We found very early that having a separate helm chart, if everyone's, quick show of hands who's used helm, just so I'm wondering the audience. Excellent. If you haven't, guys, that's the current thing you should be using. We found very early that we had separate helm charts for every application, and that made a lot of effort, a lot of work to update things. So you decide, oh, we need to turn on pod disruption budget. Oh, that's now 40 different charts we need to update. So we centralized it down to using one more complicated, but one sort of chart that made our lives a lot easier. One chart to rule them all was the running joke in the office. One of the other things that was very, very strict, and we keep to today as well, is everything is code. Infrastructure is code, our content distribution network is code, our CI/CD platform is code, everything is code. But especially 2 years ago, there were a lot of things out there. As I said, you've got your Kubernetes versus Docker Swarm, you've got all kinds of other things you've got to choose between. And you've got to, some cases you've got to make a firm commitment and lock to it, and in some cases you've got to evaluate things. One of the rules that we sort of said, and this is a quote from a colleague of mine, no is temporary, yes is forever. So there were a lot of things that we said no to, or we started off saying no to. A key example, and it made perfect sense at the time, and I'll be honest, it's probably not the best thing right today, was we said no to service mesh. Back then, service mesh was a little bit fragmented, and as you remember seeing from the talk yesterday, there's real maturity, but this is more recent than we had the opportunity to take on. Another sort of example of where changing and sort of understanding what you need is initially we were using REST endpoints. And REST was nice and made sense at the time, but it wasn't the best opportunity. We've gone ahead and we're actually now using gRPC and GraphQL absolutely everywhere across the board, and that's been really, really beneficial to us. Similarly with serverless. Serverless is great, it's shiny, everybody loves it, but it's not, or at least in inception, it was a little bit immature. There were a lot of different competing things. You've got your Knative versus kubeless versus Nucleo. There's all kinds of different, or there were especially, all kinds of different opportunities, different things in that space. And to run these systems, you've got to understand them. And to understand them, you've got to invest time in them. And it's a lot to take on if you're not careful. Secret management. Secrets are a very interesting and difficult thing that you've probably got to take on and consider very, very early. There are a lot of useful tools out there. A lot of people seem to be focusing right now on Vault, but there are other tools out there. You see other people using AWS SSM. I can't remember the exact name for the GKE equivalent. All kinds of useful things out there, but it's something that you've got to take into account from day one because retrofitting it is very, very, very hard. One of the things that you also got to take into account is your secrets change. Your vendor gives you an API key that exists for a year. You need to change it within that year time frame, and coming close to that deadline, you don't want to be having to panic to, oh no, I don't know how to cycle these secrets out, I've got to recompile all my code, and that's just a really bad path to go down. Part and parcel with secrets is access control. As we spoke about yesterday, RBAC is the big thing around access control. You've got pod network policies, you've got different overlay policies to look at as well. It is incredibly difficult to retrofit access control into your Kubernetes cluster. Just ask me how I know. It is a real nightmare, especially if you do things like, oh, every developer needs access to Kubernetes, I'll just hand them all the core root API keys for Kubernetes so they can get their work done. Makes cycling keys really hard. It's very, very difficult. This is one of the key things that you need to take into account, you need to model and plan for, because it will cause you a lot of headaches. Other thing that very important for us was observability. Observability is really, it's great to see how much of a buzzword and a key point it is today. Back then it was a bit, oh, there's something that's kind of like Nagios we can use, and that should sort all we need. It's not like that at all. There's two parts, in our view, to observability. You've got the infrastructure side of observability. You've got needing things like dashboards to report on network utilization and making sure your DNS services are working properly, which is something that burned us a bit recently. One of the really useful dashboards that we've got in the office is a giant big screen that tells us error rates across a bunch of our HTTP endpoints. And because that's big, it's out there, it's visible, every time we get a spike in error rates, people are looking at it and say, oh, why is that now an error? So we've been able to get more interest by exposing out these metrics. Prometheus is an absolutely incredible tool. Open tracing looks like it's going to go great. These tools are absolutely brilliant. The other side of your observability is your development side, your metrics. So it's great being able to generate, how much traffic comes into a pod, but you need to know what that pod's doing. Now, you can get useful metrics out of your service mesh, as we've seen from yesterday, but sometimes that's not everything. So you need to have a lot of energy focused on getting your applications to report useful metrics. If you're familiar with the RED, USE and golden signals, these kinds of metrics. How often something happens, how long it each takes. Do you have lots of requests in flight? And these kinds of metrics you can utilize to use auto-scaling and horizontal pod auto-scaling and tools like this. A really useful metric that we had in some of our applications was the frequency by which articles were being published. So that sort of gave us a really key indicator of if everything's healthy. Microservices. A lot of people talk about microservices these days. A lot of people were talking about microservices back 2-ish years ago, and especially 2-ish years ago, not many people knew what they were talking about, which was unfortunate. One of the things that we sort of saw, you go to various meetups, people would talk about taking a giant big monolith, taking it into 3 parts, and then calling it a microservice. But if you take a giant monolith, break it into 3 parts, you now have 3 monoliths to support. It's a bit of a false economy there. One of the speakers yesterday, my apologies, I don't recall who, mentioned that a really good way to look at your microservices is from the business requirements, the business drivers. Ignore the tech for a minute and look at those kind of requirements. So that's a good way of looking at it. But again, microservices is not just divide and conquer. It's a very different beast, and you kind of need to have a team of developers that understand that. It's not just a traditional whack everything in your Java Tomcat monolith app. JSON is great, but JSON was predominantly designed for a browser to server, server to browser type communication. So your JSON's over HTTP, it's designed for serialization to the browser, different platforms and all this. It was good, but it's not good enough for service to service or server to server type communications. So we found early on that we addressed a lot of our internal problems by switching across to gRPC. gRPC runs over HTTP2, so if you're looking as a network engineer, as some of us were, it's still a known quantity. It's not something crazy and different. It's still something that's understandable to us. Different kind of payload, but we can still understand it and make sense of it. One of the other real key things we found in gRPC was this type safety. If you have a JSON payload, you change your object types, it can lead to a very, very sad day when you accidentally make it a string when it was a Boolean before, or vice versa. So this gRPC has been really key for us for that. We've got a bunch of new developers taking on microservices, new patterns. We needed a way to bootstrap them, to get them started on a new way of doing things, a new world, if you like. One of the key things that we needed to do was make sure that everybody was following a similar pattern with their metrics, because if everybody writes metrics differently, you've just got lots of sprawl, not very useful. So we needed a way of commonalising a lot of things and bringing these new people along so that they can get started. If everyone remembers one of the talks earlier, yesterday, one of the key problems that people have in a new organisation is getting started, getting bootstrapped up from scratch. And this was a key one we had. Now, we took a different approach. We, instead of providing a bunch of libraries that people should glue together, we basically provided some boilerplate. So here's your Golang boilerplate. It's got your metrics all hooked in. It's got Jaeger tracing running and ready to go. It's got our standard logging and our other methods. It's got our standard health check processes and patterns. It's all using gRPC. It's all nice and shiny and buzzword compliant. It's got all of our CI/CD platform all running there. And one of the things that was very useful for us was all of this is a single repository together. So the development teams are able to work on all of these things, the CI/CD, the infrastructure pieces, the components that describe which AWS or GC resources they require are all there together in their one repository. But this is a lot to take on. This is a lot to start with if you're a new starter. It's a crazy amount of new things to take on. So one of the challenges, one of the problems is how to bring all these people on. We can provide them code, but there's more than just code to understanding what's going on now. And as I said, this is a bit of a business reboot. We've got people who are used to developing for a monolith that are being told, no, you don't do that anymore. So it's almost like a cultural or a technical cultural change. So how do we sort of do that? So we need a way of sharing, passing around knowledge. So internally, we have a number of different, again, less technical ways of sharing knowledge, passing it around. We do brown bags, sort of lunchtime sessions. We actually now have a quite extensive internal training program where people can learn all about all kinds of different things. One of the sessions, as an example, that we do in our internal training program is bring people up to speed in Kubernetes. And in this deep dive in Kubernetes, it's all and more a developer would need to know about Kubernetes, debugging their application, and all of this. Another course we do a fairly deep dive in CI/CD, in our CI/CD platform, more than you'd possibly need to know, but it's interesting. And we've got different levels of these subjects. We also quite heavily focus on, or quite heavily prioritise, getting involved in open source. If you want to make a change to an application, you can fork that application, make your local change, and then use your local fork forever and a day. But if you push that change back, if you give that back to the community, they help support it for you. You get that feature in the next version, the next version, the next version after that. So definitely getting involved in open source has helped us quite significantly. An example of that is some features that we've needed in the secret management platform. We've been able to open source that. We've been able to talk back to the core developers. And I think a recent version, we've got these fairly significant RBAC type changes implemented out in having a mental blank on the application now. So yeah, open source, training, and giving people time to have a bit of a play, a bit of understand, try a few things, see what happens. All of this too, this is not just the operations engineers or your developers, this is sort of the whole division wide. So just looking at our SRE/DevOps/platform engineering, so many labels in this space, it's really hard to keep track of what people are saying and the business titles people use and job adverts is crazy. One of the things that we've found with this pattern is we've been able to promote you build it, you owned it. You own it, sorry. So because a developer can come along, create a new application, create a repo, fork off the skeleton, push it off, deploy to production without talking to any of the other teams, they feel more of an ownership of it. And it also means that if they do that, they get any on-call alarms for it. So it's made it a lot easier for us in the engineering space to be able to support all these apps, to be able to support the infrastructure that keeps them all running. And it's made our lives a lot easier. We've pushed very, very heavily on GitOps/SlackOps/ChatOps//ops methodologies so other people can do things without us needing to do absolutely everything for it. Another thing that has been really, really key, critical, and almost a lifesaver is very, very strict pre-deployment checks. So merge request or pull request checking, being very, very strict, aggressive linting. In early days, you'd see, people complaining, this linter caught this problem that I don't really care about. Well, no, you fix the problem. You keep it to this very, very strict quality guide. And this kind of culture has made our lives a lot easier. We've written better applications, faster applications, and being able to deploy them to production much faster as a result. And all of that's meant some significant benefits to the business because we've had, as I said, people could start a new application, write it and have it in production in probably, I think in some cases, has been a day to 2 days. So business coming along saying, oh, we need X done, they've been able to turn around that really quickly. In the old monolith pattern, we had a release train that ran every 3 weeks. So if your feature didn't make it in 3 weeks' time, in that 3 weeks, you had to wait another 3 weeks. And it really wasn't fast enough for the business because that's a 3-week cycle. You've got features, you've got staging to propose to go through. I think in one case, there was actually a measurement somebody did. And from request of feature to actually seeing it in production, I think in one example, it was taking 12 to 14 weeks. That's too long. And especially if you're competing against blogs and Twitter feeds and things, it's just not fast enough. So we found that with this pattern, with this splitting up in microservices and this particularly division of responsibilities, this development teams now own their own problems, that we've gotten to actually hitting production. I think the stat was something like 12 times a day on average for each. It's probably a bit higher. Some of our current applications are going 100% CI/CD, constant delivery all the way to production. So I don't even have those stats. I'm sure they're pushing probably more than 12 times a day. Through all of this, we kept having our page views, the number of people come along, the number of subscribers to our websites, number of subscribers to our newspapers constantly increase. So we were constantly able to prove to the business that this was a good bet, that this was something that was valuable to the company. We've also been able to sort of prove that important things happen. The business says this is important, and it can happen. There was an example probably about 3 or 4 months ago, it was sort of a key good example, where the business came up and said, oh, we urgently need X done. And that feature was in production, I think before close of business, that same day that they asked for it. And this was unheard of previously. Keep in mind, we're talking a 190-year legacy company with monolithic Java applications to hitting features to production the same day. It was a complete change. However, this is, as the title suggested and as the island metaphor implies, it's a journey. We've still got other places to go, we've still got other things to do, so it's not the final state. There's a few things we're looking at. A lot of the team have been taking a lot of notes about service mesh over the last day or so, so there's something that we want to hit pretty hard. We want to look at networking in Kubernetes quite aggressively because we're not very happy and comfortable with how networking's working for us right now. We need to step up some of our testing processes, and we would like to be more aggressive and more, in my view, correctly using canary deployments and the canary model. So that's the kind of stuff that we're moving towards. Would anybody like to throw any questions?